Hey there, welcome back to Coding at Home with the Code Hub. All right, so today we're moving on to a new topic. We've gone through commands, we've gone through functions, we've gone through variables, we've done conditionals the last few days, and we found some really interesting uses for conditionals, including the quiz that we saw yesterday. And we're going to come back to that quiz today to talk when we're talking about types and initializers. That sounds a lot more computery, a lot more complex maybe than the stuff that we've covered so far. And if you're brand new to us, you might want to start with the videos on this Twitch stream. There's also the kids.code playlist on YouTube that's worth checking out. There's a getting started video that will walk you through getting Swift Playgrounds onto your iPad and the right books into your books application. Now, you don't need the books, especially if you're following along with us, because we'll kind of walk you through the material in the books and the playgrounds at the same time. But they're really nice to have. They're well written, they explain the concepts well, and it helps to go over these things over and over again until you get it. So today's topic is a little bit more complex. We're talking about types and initialization, and we're going to see that the way we've been organizing our code with functions, with variables, with for loops and conditionals, there's lots of different ways to organize our code. Types give us another way to organize our code. So let's go jump to the iPad and we'll check it out. All right, so here we are. We're going to be working in Swift Playgrounds again today. We're going to be working out of the Everyone Can Code Puzzles book still. So we've done conditional code. We've covered all of these playgrounds. Hopefully you've practiced a little bit with boxed in and decision tree. So we're going to skip through the rest of this book here. And we're going to take a look at the next chapter, chapter 6, types and initialization. So far we've been using a lot of this stuff under the hood and maybe we haven't quite realized it. So we start talking about, when we talk about types, I mentioned that we organize our code. It makes reference to the, how do you know that your cat isn't a dog? Well, these things out there, like a dog, like a cat, have certain properties. We would represent them with variables probably, right? So there'd be things like number of legs, hasWhiskers, and the properties themselves are going to have types of their own. So you know what, I really like the way the Swift Playground explains this. So let's leave this behind for a second. We're going to go skip a couple of pages here and check out the playground pages that we're going to play with today. So we're going to be jumping into the Learn to Code 2 playground. Back to that old thing. We have been in Learn to Code 1 for most of these sessions. If you don't have it downloaded already, you can go down here to the See All button. So if you didn't follow what I did, because I did it kind of quick there, I opened Swift Playgrounds on my iPad. I hit the See All button down at the bottom here. And like we've seen before, at the very top, we have all of our Apple authored content. So we have Learn to Code 1, Learn to Code 2, Blues Adventures, and then a few other really fun projects to work on. What we're going to do is we're going to tap on the Get button to get Learn to Code 2. Now, if you already have this downloaded and you followed me in here, we can just hit My Playgrounds to go back. So I'm going to go open up my Learn to Code 2 copy 3. Now this starts me out at the very beginning. And like we've seen in some of the other playground pages, it starts us out with a handy little tutorial on what, in this case, variables are. And we can see if we tap up here on the title, we can see the introduction. We've done keeping track. When we were working on variables, we've got this bump up the value, incrementing the value, a few other playgrounds that we skipped because when we were learning about variables, we didn't want to quite jump into that level of detail. Now, though, we're going to jump into types. So you need to scroll down in your table of contents and get to the introduction for types. So they subtitle this one Smart Blueprints, and we'll see what they mean now. All right, so if we want to build a house, we use a blueprint. Basically tells you how you should construct a house. So the reason why I really like this analogy of a blueprint is that you use the blueprint, you write the blueprint once, and then you can use that to build multiple houses. So in this case, you can see that they all look similar. You know, they've got the same number of windows in the same place. They've got a garage. They've got a door in the same place. They're different colors. So some of their properties can differ, though, once they actually have an instance of that blueprint. You'll hear that language a lot. In other languages, you might have heard it called a class. Swift has a couple of different ways of representing that. So that's why we call it a type. So, like it says here, blueprint shows the features and behaviors of a house. Some of the features might be the color, the bedrooms, the number of bedrooms. And then it has certain behaviors. Like you can ask it to run the water or turn on the lights. If we were back to our cat or dog example, we would have number of legs would be our features. hasWhiskers would be features. Behaviors would be what? chaseStick, makeNoise. Those would be our behaviors. So when we have a type, those features like color and bedrooms or hasWhiskers are going to be properties. And if you look at properties and the way they're defined, this looks a lot like the variable stuff that we've gone over, right? We've got var color equals, and we've got a color swatch. And we say var bedrooms equals 2. Right? That's exactly the stuff that we covered during our variables lessons a couple weeks ago. And then over here, we have a header called methods. And we see run water with an open and closed parentheses, and then turn lights on using camel case, right? So the first letter is lowercase, and then the first letter of the next word is uppercase, and so on. And then it's got a suffix of an open and closed parentheses. Now, we saw this when we were going through the functions pages way back in the very beginning. That was the syntax for creating a function. Well, a method is basically just a function that's on a type. And we're going to see what that means in a little bit. So in this case, we say we've labeled our different instances of our house. Her house, my house, his house. These would be our variables here. So we would refer to this house by name, which is her house, my house, or his house. And then we're going to tell it what to do. So we have that behavior, that method defined on our house blueprint called open garage door. So now we can tell any instance of my house to open the garage door. Now, if you don't get this straight off the bat, don't be too frustrated. This is much heavier than a lot of the stuff that we've gone into so far. Conditionals were pretty heavy. This is another leap again in our programming knowledge. So we'll take it slow. We'll probably cover this chapter for a couple of these live coding sessions. So we have this thing called dot notation. So we have my house, which is that variable that we had. We have a dot that says, okay, I want to call a function on my instance called open garage door. And you can see here that her house, the garage door is closed. The garage door for his house is closed. The only one that's open is my house, because that's the instance that I called it on. So when we get to the puzzle, we're going to be working with this property on a portal. So our portal is going to be an instance of a portal type. And they have this property called isActive, which we can set to true or false. So let's go try to solve a puzzle using this property on our type. Okay, so our goal here is to deactivate the portal to reach the switches. Let's wait for this thing to load. All right, here we go. We can see that we're going to have 3 switches to toggle on, and none of them are toggled on right now. We can also see that we have this portal right in the middle of our path. Now, it's as it says here, we've called functions in a general way using move forward or turn left. So if we say, all right, let's start writing our code. We have a line of code here called greenPortal.isActive equals true. So we'll look into that in a second, but let's just try to get to this switch over here. So we'll move forward a couple times. Once, twice, 3 times. That puts me here. I'm going to turn left. I'm going to move forward, move forward, move forward. So 3 times I'm going to move forward. And then I'm going to try to toggle the switch. So we've already written a bit of code. We've also written a bit of code that's kind of repetitive. We've got 3 move forwards there. Maybe we want to make that a function. But let's try running my code to see what happens with Hopper. So she moves forward again, moves forward again. And the portal's active, because we can see here isActive is set to true. And then we strand her over here on this little island. So let's stop so we can stop Hopper from dropping off the edge. So let's look back at their advice here. We have the hint down at the bottom. You'll remember we can tap on the hint. And it says, first we'll need to set the isActive property of greenPortal to false. Remember, we can tap on these blue words to get the definition. So a variable, a named container that stores a value defined inside a type. So property is just a fancy way of referring to a variable when we're talking about a type. Just like method is a fancy way of referring to a function that's defined on a type. All right, cool. So we'll close that one. We have no more hints. That's it. So let's try tapping on that and turning this to false. So you can see when I tap on that, it turns blue. I have a false option there. I can actually just tap on that. And let's run our code now. Okay. Cool. So you can see that the portal actually turns gray now that we've got the property isActive set to false. Okay, cool. We just toggled one switch. All right, now we need to go back and we need to toggle all the rest. So we could keep writing this all out, or we could take a look at these arms here and say, well, if we're in the middle, we go out and we get them to come back. That might be a function that would be useful for us. So we could call that solve arm. So let's write a function called solve arm. And we can put this, we can put this above or below the green portal, but let's put it below. Let's say solve arm. So that is my function. And now I'm not defining it on a type. We'll see how that's done in a little bit. It's just a function all on its own. So we still call it a function, not a method. So I'm going to tap on function body and let's see. Well, actually, you know what? We can drag this stuff in, can't we? So let's tap, instead of tapping on the function body, we're going to tap on the closing brace and we're going to drag down. Maybe get rid of some of that. So we can, let's see, is that going to solve it? Well, this move forward part we did first. So maybe we should get rid of this. Get rid of this. And all I'm doing is I'm just picturing where Hopper is when I'm standing here and I'm facing this way. So, and then I want to get rid of that turn left. So I'm imagining I'm standing here facing this way. So I've gone 1, 2, 3. I've toggled the switch and then I need to turn around and come back. So let's turn around and come back. So we're going to turn left and then turn left again. And then we're going to move forward 3 times. And I'll worry about turning and facing the right way in my code outside of my function. So that's solve arm. Okay, so let's see, I start out here and I need to do my 3 moves forward. Move forward. Now, if you do happen to do what I just did there, where you drag your application off and you move to the next, and you find yourself in books, just either double click the home button or click it once and then tap on Swift Playgrounds to get back into Swift Playgrounds. So we're going to move forward. Oh, I'm going to crash myself. So we're going to reopen it. Let's try that again. And the nice thing is that now that you're becoming more of a programmer, you can appreciate when other applications crash, which is what Swift Playgrounds did just there. You can appreciate how difficult it is to write that code so that your application doesn't crash. All right, so here we go. We're going to move forward. We're going to move forward again. And we're going to move forward again. Now, we're going to be on the portal that we should have turned off, which we did up here. We're going to turn left. And then we're going to call solve arm. And solve arm is going to bring us back here facing this way. So you know what? We can actually just call solve arm again. And then Hopper's going to have come back this way and be facing up. So we're going to turn right and then solve arm. And I think we're done. There was our turn right. There's our solve arm. Okay, well, let's try stepping through this. And we'll watch, and you'll see when the code gets to this line, that's when the portals turn gray. So let's tap on the little speedometer and do step through my code. We've turned off the portal. We're now moving forward, turning left, solving the arm. So we jump into our function that we defined. Hopper's going and jumping on the switch. Now, if this was one of the previous puzzles where the switch might be on or off, I might have put a conditional in there inside my function to say if we're on a closed switch, that's the only case where we toggle a switch. I might have also put these move forwards into a loop. That might have been handy. Like we've mentioned, there's a number of different ways to solve these puzzles. Right? Now we've flipped all of our switches. We're running a little bit of extra code at the end, so that's something else that we might want to fix. And there we go. So we did it. We use dot notation over here on our portal. So this is an instance of a portal. Dot is active equals false. To set it to false to turn off our portal. Again, we can see more of our definitions here. So you can see here, we use the let notation. So if you remember back to variables, we tried to focus on the var keyword. You can also create variables with the let keyword. And there's a little subtle difference there. But in this case, we said let green portal, that's our variable, equal portal. That creates a new portal for us from the portal blueprint. And then we're able to switch this is active to false. Now, if we had another portal on here, like a blue one, and we set the green portal is active flag to false, it doesn't mean that the blue portal flag is going to turn off, because that belongs to just that instance of that type. Now that's all we're going to actually cover inside this part of Learn to Code 2 is this one page, deactivating a portal. Now, if you want to practice after this session, it's definitely worth going through these other pages, portal on and off, setting the right portal, corners of the world, and random gems everywhere. You're going to use a lot more of your tools like functions, for loops, conditionals, and also now setting properties on instances of a type. But what we're going to jump to now is initializing our types. So let's go down to initialization and this introduction here. So initialization is just kind of a fancy way of saying creating the new. It's taking a blueprint and creating ourselves a new house in the previous example. So now we're getting exposed to a few more types, right? So we have a portal type that we did some operations on. We set a property on it to false. There's another type called character. And that's actually what byte, hopper, blue have all been. They're characters. So this character here would be an instance of a character type. This might get a little bit confusing when you start talking about it. If you have an instance of a character called character. This is why I like this particular naming convention over here, where we've been a little bit more specific about, in this case, what color our portal is going to be. Because we can see that we have two instances of a portal here and just one instance of a character here. So now they've written a new character type for us called an expert. So we have all the expert will have all of these behaviors. So a character has move forward, turn left, turn right, collect gem, and toggle switch methods you can call on an instance of a character. If you create an expert type, an instance of an expert, you'll have move forward, turn left, turn right, collect gem, toggle switch, and a new method called turn lock up. And we'll use that to solve our first puzzle here. So like I mentioned, this is how we initialize an expert. It looks a lot like a function. You can see this is why some of the rules about capitalizing different types of capitalizing a variable and using camel case for functions and variable names comes in kind of handy, because all of our variables so far have started with a lowercase letter. And typically, our types will start with an uppercase letter. You don't have to do this. It's a really, really good idea, though, because it's a convention that most programmers who use Swift use, and it helps you read other programmers' code, and it also helps them read your code if they're helping you out. As I mentioned, we're using the let keyword here instead of the var keyword to define our variable. And so what we're saying is okay, cool, we have a variable called expert, and we're going to store an instance of an expert type inside that variable. So you remember we had the example of the boxes. I have a box, and I'm saying, hey, I'm going to store an expert instance inside that box, so I can refer to it later. So just like we changed the property by saying blue portal dot is active equals false, we can call methods on an instance of our type by using dot notation. And just like with a function, our function name is suffixed with these open and close parentheses. And this is where we've used this language before, where we said, oh, we're going to call a function, we're going to execute a function. Same thing, you'd use the same kind of language when you're talking about a method. So there's a note here saying you must initialize expert before you can give it instructions like move forward. So let's check this out. Because this is a lot more advanced, we do get a little bit, we'll have more errors in some cases, and we'll get brand new cryptic error messages that we need to try to figure out what they mean. All right, so if we run our code down here, we can call, let's try calling expert. We'll bring up the keyboard, we'll say dot, move forward. Now if I try to run my code, I'll get an error here saying I need to fill in this placeholder. Well, Remember, it was just telling us we need to initialize it first. So we can see here, this is how we initialize it. We use expert, parentheses, and it'll complete both for me. So if I run my code, we're going to see our expert shows up on the arrow and moves forward once. So you'll note that before I ran my code, there was no expert on the puzzle. This is because we have to now create the expert to run around the puzzle. So I can also initialize a character. If I hit run my code. It's taken a while to think about it. Ooh, so we're getting a hint. Something didn't quite go right, so let's take a look at the hint. So it's expecting an expert type here. So we'll need to go change that back to expert. And now if you're coding in Xcode, you'll actually see a different type of error if you're using a type that your code is not expecting. And we'll get into that when we start walking through app development with Swift in a few weeks. Okay, so we've called our function. Now before, we were just calling move forward because under the hood, the Swift Playgrounds engineers and the author of that particular Swift Playground, Learn to Code 1, had written it so that if you called move forward, it had an instance of a character already, and it would just tell that character to move forward. Basically what we're doing now. So they were kind of doing the dirty work for us. Now we're having to call this method on our expert. So we're going to move our expert forward. If we look here, this is the lock. So we're going to go here, turn the lock up, and we'll see that this platform here will be raised so we can now access this gem. So let's go turn that lock up. So we'll hit move forward, hit return. We're going to call expert. And if you look down here in the autocomplete bar, you'll see that a lot of my functions from before, like move forward, turn left, they're gone because they don't do anything. And in fact, if I try typing it in myself, type in move forward in my function, I'll try running this code and it'll give me an error. It says use of unresolved identifier move forward. That means that no one has defined this function move forward anywhere. So I'm not able to use it because Swift knows nothing about it. So, all right, let's tweak this. There's a couple of ways we could solve this problem. The easiest and most Swift-like is to just go here and pick, I want my expert. And I'm going to add, it gives me the dot for dot notation. Cool, so now I've moved forward twice. Let's see, I'm here. I need to move forward again. So I'll hit return. I'll call the same thing again, expert, dot, move forward, hit return, and now I'm going to call expert. I want it to perform a certain behavior, so I'm going to hit the dot, and these are all my options. Now I see turn left, turn right, toggle switch, move forward, whether or not I'm on a closed switch, if I'm blocked. So these are all properties on my instance of the expert. So I want to turn the lock up. So let's check it out. Let's see what happens when we run this code. So we create our expert. Oh. We'll try running that again. Give it a second. Actually, let's do our favorite old trick of we're going to navigate off of this page. And then we're going to navigate back onto it by hitting this arrow. I've still got my code there. Going to wait for the puzzle to load. There's the puzzle. All right, so if I hit run my code, There goes my expert. Oh, there I go. Turning the lock up. And there goes my platform. Great. Now I have everything set up so that I could go solve this puzzle. So let's try this out. So this is an example here of us using calling a couple different methods on our expert. So let's go down here. We want to collect our gem. Let's see. Instead of doing collect gem and turn around, maybe we'll try to do this in a loop this time. Is there any way we can do that? Well, if we turn around, we want to go up 1, 2, 3, and then turn left, and then go 1, 2, 3, collect the gem, come back 1, 2, 3. We'll be facing this way, turn left again, collect the gem. So all right, so let's get ourselves to turn around. So we'll say expert dot turn left, and then we'll do expert dot turn left again. And now we're going to have our for loop, and we're going to do it 3 times because we want to collect 3 gems. Again, this is something that maybe we might need to play around with if we haven't walked through it in our head. We might say, all right, look, let me just solve it once to start with and then see if I can loop it. So let's see. We're going to move forward 3 times, we said. So we're going to do expert dot move forward. And we're going to do that 3 times. Now we could get super fancy and do a loop there, a loop inside of a loop. That might be kind of fun to do. Let's try that out. Let's do. All right, so we're going to do it 3 times. We are going to move forward. So I tapped. Oop, I don't want the hint. I want to tap on the bottom brace and drag it down. We can see now I've got a loop inside of a loop where I'm going to move forward 3 times. And then after I've moved forward 3 times, I should be in the middle. So I'm going to then turn left. So I'm going to do expert dot turn left. And then what am I going to do? So I've gotten back to here. So now I want to go out here. So I want to move 3 times. So let's do another crazy for loop where we do expert dot move forward. Now we're on top of the gem, I believe. So we'll do expert dot collect gem. Now we need to turn around and move back. Right? So let's turn around. So we'll do expert dot turn left, and we'll have to do it 1 more time. I could get really crazy and do a for loop twice, but maybe that's kind of overkill. So let's see. So at this stage, we've started off this loop after we've turned left and turned around, after we unlocked or turned the lock up and raised this platform. We've walked all the way back up here. We've turned left, and then we've come all the way down here. We've collected the gem. Now, if we look at our loop, if we jump back out, we would move forward again. So we're turned around. We could move forward again 3 times. We'll turn left. We'll go out 3 and come back. That seems like that might do it. So let's try running this code, and we're going to step through it so we can see every loop get run here. So now we're telling the expert to move forward, turn the lock up. There comes our platform. We've turned around. Now we're into our first loop, and our loop inside of a loop where we're moving forward 3 times. Okay, we've turned left. We're entering into our second loop inside a loop. Oh, cool. We're underneath the gem. We collected it. We turned left again. And now we're running through the loop again, going forward 3 times. And then off we go. We're in our second loop within a loop. We're collecting our gem, turning left, turning left. Oh, cool. Here we go. We've turned left. I think we're in our last run of our loop. Turn left. We're going to come back to the middle. Nope. Well, we're not because we ended here, right? All right. So we did it. We initialized our expert here, and then we called a bunch of methods on our expert to navigate him or her around our puzzle. Now we're going to stop there for today. There's another puzzle that we typically would try to solve in this Everyone Can Code Puzzles book. So if we go back to the book, you can see here, there's using instances of different types. This is where you'll see the power of using these different instances of our type. So if I go back to the playground, so we only have one expert running around this puzzle. But now that we know how to initialize other experts, we could create 2 experts or maybe an expert and a couple characters, and we could have them go off and collect gems for us instead of having one character go all around the puzzle all by themselves. We're going to play around with that a little bit tomorrow, but feel free to try it out yourself at home. Have a read through the puzzles book and see if you can, there are things you can practice. It gives some really good examples of how to start to create your blueprints, how you think about things. It gives a good example of an iPad and how you might break that down to different properties and behaviors. It talks about cats and dogs. Those are always a favorite when you talk about programming and types. But we'll get back into this a little bit tomorrow. And yeah, this is good. This is good stuff and not the easiest stuff. So this is a really exciting step in your programming journey. All right, we'll see you again tomorrow at 1 p.m. Irish time. Have a good one.